Okay, folks, we just finished doing a video where we talked about how to go from logarithmic form to exponential form. And we also did a video prior to that where we did the reverse. We went from exponential form back to logarithmic form. Anyway, all of those skills are really useful before moving on to this video. So check those out if you haven't already. Okay, so in this one we're going to solve logarithms using the change of base identity. Don't worry about that crazy looking expression. Basically what's going to happen is you're going to be able to do these questions very quickly on a calculator. That's the bottom line. Let's look at them the slow way to begin with. In this question here we have the log of 8 to the base 2, and we're supposed to figure out what that equals, and we'll say that equals y. We don't really know what y is. It's the exponent that we're looking for here. So the way you would change this from logarithmic form back to exponential form is you'd write the base 2, just like that's the base 2 right there. You write the base 2 here. Then you put the y, that's our exponent that we're looking for, and that's supposed to equal 8. The way you would say it, once again, is the log of 8 to the base 2. Okay? So if you were to take a calculator or just do it in your head, you know that 2 to the power of 2 times 2 is 4, 4 times 2 is 8. 2 to the power of 3, or 2 exponent 3, is equal to 8. If you don't know that in your head, you can easily check that out on a calculator. Here's a calculator. 2 to the exponent 3 is equal to 8, as you can see. All right? So the answer in this situation, well, y would be equal to 3. Okay, that would be our answer. All right? I'm tempted to show you right now how to use the calculator to solve this. Should I do that right away, or should I do all of these the slow way first, then show you how to use the calculator, just to increase the excitement with the answer? I think I'm just going to let the cat out of the bag. Boy, I'm terrible. It's a good thing I'm not exposing Santa Claus today or anything to people, but I'm just going to show you. To solve this question, you would look at this situation and you would see log of 8 to the base 2. So you start by typing, look for log on your calculator. Some of your calculators you have to hit 8 first and then log. On this fancy calculator, you just take log 8 and you divide it by log 2. Where did my log button go? I'm sure you're telling me, but I can't hear you. There it is. Okay, thank you. Check this out. It tells you that the exponent would be 3. Isn't that amazing? I don't know if it's as amazing as if I would have waited to tell you, but I've just shown you. And suddenly, we know the exponent. The exponent was supposed to be 3, or y equals 3 in this case. All right? If you have an older style calculator, I'm going to try and I'll get rid of that one. If you have an older style, you can still do this, but it's just a little trickier. You have to go first type 8, then log. You get this crazy looking thing. Then divide it by 2 log, and then hit equals. Ta-da! You get a 3 there. Hooray! Now I much prefer the this calculator here, but anyway, let's move on to the next question. Okay, let's say this thing equaled y, and we have log of 625 to the base 5. Okay, so what that's saying is 5 to the power of what, or y in this case, is equal to 625. You might need a calculator no matter how you do this, because if you were to guess and check, you would have to guess 5 to the exponent. If you went 5 exponent 3, that's 125. We're not quite there yet. So 5 exponent 4, let's try that. There it is, 625. So 5 exponent 4 is equal to 625. And therefore, we now know that y, boy, y's and 4's look a lot alike, but I'll try to make it look differently. There we go. We know that y is equal to 4 here. Okay, and we've just solved it. If we had done it the fast way, you remember what to do? You hit log 625. I'm going to close the bracket because I think I need to, and then log divided by log 5. And you get 4 as your answer. Look at that. These calculators with the log button are amazing. Who knew logs could be so easy? Let's look at the next question. We've got 2. And let's just say this equals y again. 2 to the power, or 2 exponent y is equal to 1 over 32. A little trick here, but not too bad, because we know from previous videos on negative exponents that if we could come up with 2 to the power of what is 32, let's do that right now. 2 to the power of, let's try 4. 2 to the power of 4 is 16. 2 to the power of 5 is 32. Perfect. So 2 to the power of 5 is 32. All right? Then how would we make it 1 over 32? Well, you have to recall from a previous video that if we make the 5 negative, that's the same thing as saying 1 over 2 to the power of 5, which is 1 over 32. If we wanted to, yeah, I guess I'm going to stop there because that explanation is something I have to assume, for the sake of time, that you have watched a video in the past on negative exponents, okay? The bottom line with this video is that we should get negative 5 as the answer using this change of base identity. So let's try typing in this weird situation on the calculator. We're going to go log and then 1 divided by 32, close the bracket. We're going to take that and divide it by log 2, log the base of 2. And look at that, you get negative 5 as an answer, which is exactly what the calculator told us. Okay, this must be getting a little redundant for you to watch, but I'll just keep going. 2 to the power of y, or 2 to the exponent y, is equal to 64. Well, what would it be? You guess and check. 2 to the exponent, let's try like 5. Okay, it's going to be 6. 2 exponent 6. Hooray. 2 exponent 6 is 64. We just verified that, so y is equal to 6. That's the mystery exponent that we were looking for. Using the change of base identity and your calculator, you know what to do. Log 64 divided by log 2 equals, and as you would have guessed, we got 6. Okay. Here's some questions that I don't know, a teacher might give you just because they don't want you to use the calculator so quickly. So let's think about it. Let's say all of this is equal to y. So x to the power of, or x exponent y is equal to x to the power, or exponent n. I like to say x to the power of n, but I know technically I'm probably not saying that right. So I'm supposed to say x exponent n. Anyway, hopefully you folks aren't too picky out there, because I'm not. Anyway, what we can say here is because x to the power of y, or x exponent y, is equal to x exponent n, that means y and n must be equal to each other. They must be. So the answer is simply y equals n. N is the answer we were looking for. I know that's a strange question. You might never get one like that, but if you do, you've seen it here. Let's try one more. A exponent y is equal to a, and we're supposed to come up with what this would be. Well, we know that there's an invisible 1 here, so suddenly we know that because these bases are the same, you can take down the exponents. Y is equal to 1. It has to be. Okay? And that makes sense because let's say on a calculator, let's pick any number we want for a. Let's say log 200. Let's say a was 200. So just log 200 divided by log 200. The rules of math still apply. When you take something and you divide it by the exact same thing, you're going to get 1. And that's what we got. Okay? So the change of base identity, and you can always pause it on here just to review and read this, but I was supposed to reveal at this point in time how great the calculator was at getting these answers. But there's no need for that because you already know how. One more question. You may come across a question like this. All we have to do, use our change of base identity, and we can quickly figure out what each one of these are, and we'll have our final answer. So let's just use our calculator. We've got, I'll move it over, log 81 divided by log 3 is 4. There we go. Let's do the same thing here. You can almost guess what, you pretty much know what's going to be. Like 3 squared is 9. However, I'm just going to do it the slow way here, or the so-called fast way. It depends how you want to look at it. Log 9 divided by log 3. And sure enough, it's the 2 that we were guessing it would be. Well, what is 4 plus 2, folks? This is the tough part. I'm just kidding. 4 plus 2 is 6. If 6 would be the answer we are looking for, the change of base identity makes things very quick. It also works for questions that aren't so nice and neat. Okay, it works for questions where you might have a decimal answer, for example, or a number that's not as obvious. For example, 2 to what power would equal 5? And you would say, wow, I don't really know what to do here. This is crazy. Well, you could change it into a logarithmic situation and say, okay, well, that's log 2. That's the base of 2. So log 5 to the base 2 is equal to what exponent? You could do this, and you would take your calculator, and you would go log 5 divided by log 2. And next thing you know, you would know that approximately, like the exponent's going to be approximately, I don't know, let's round it off, 2.32. 2.32. So in the past, someone could have said 2 to the exponent what would be 5, and you would have to guess and check and whatnot. And if you want an exact answer, someone came up with logs, and man, are they ever nice, because suddenly we're able to get the almost, well, this is the approximate answer, but it's so close to a very good answer. Okay, I've said enough. I hope I haven't confused you too badly. Carry on and have a great day.